Thank you very much. Everybody hear me okay? All good? Cool. Brilliant. So, webhooks. What's the worst that could happen? Before we get into that, let's do a little bit of an introduction of who I am. My name is Marcus Noble. I'm a platform engineer at Giant Swarm. If you want to shout at me or correct me or give me just general feedback about how this talk goes or anything in general, you can find me on Mastodon at marcus@kh.social, or other places on the web can be found at marcusnoble.com. I love to chat with people. I've now got about 6 years of experience running Kubernetes in production. Over that time, I've had different roles. So I started as an app developer, like deploying Node.js applications onto Kubernetes. I've done more of a R&D kind of role, building out tooling for other teams within a company. I've done platform engineering, and I've done CI/CD tooling, things like that. And over all of those years, one thing's kind of stuck with me with Kubernetes, and that's how they use webhooks and the kind of power and stuff involved in them. That's what I want to talk about today. So webhooks within Kubernetes are powerful things, but with that power does come some risks that you need to be aware of. So that we're all on the same page with what I mean by webhooks, I am specifically talking about validating webhooks, mutating webhooks, custom resource conversions, these kind of things that are built into Kubernetes and are a feature of Kubernetes itself, not just general webhooks that you'll see from like GitHub or whatever. So we're going to be talking about validating webhook configuration and mutating webhook configuration. These were introduced way back when in 1.9 as a beta and have since become quite a staple of Kubernetes. There's also custom resource conversion, which was introduced in 1.13. So this is related to CRDs and converting from one version to another kind of automatically. We're not going to be talking about those ones today. And then finally, validating admission policy. Not exactly a webhook, but kind of fits the same sort of thing within Kubernetes. These are brand new. So they were alpha in 1.26 and are beta as of 1.28. Hopefully, they become stable soon. Now, there's quite a lot of like purposes, use cases, and stuff with webhooks within Kubernetes, and generally speaking, I see them falling into these 4 areas. So defaulting logic, so you can use a mutating webhook to provide some defaulting logic. For example, injecting of image pool secrets into all pods within a namespace so that your developers don't need to actually have that in their own manifest and things like that. Injecting of sidecars, so we just heard the previous talk with things like Istio back in the day. That's how it injected its sidecars using a mutating webhook. Policy enforcement, so in a lot of like enterprise environments, you have rules such as don't use the latest tag within your Docker containers because it's mutable and it can change and it can be surprising. So you can enforce that with a validating webhook. Similarly, there's best practices, so enforcing the use of best practices within your clusters. So making sure that your deployments have a pod disruption budget or a minimum number of replicas, things like that. And finally, my favorite one by far is problem mitigation. So I've seen a lot of examples of webhooks being used to prevent security exploits and kind of get around them and stuff. Who remembers the log4j vulnerability a little while back, a few years back? Yeah. Pretty big thing. With a webhook, you could effectively turn that off in your entire cluster and make all the pods in your cluster safe. The way that the vulnerability worked, it was a particular code path. And you could turn that off by setting one environment variable, and then you effectively shut off the entire vulnerability. We were able to do that with a mutating webhook so that every pod that launched had that environment variable injected into it, regardless of whether it was actually Java or not. It didn't matter. And then we had an entirely safe cluster-ish. So let's have a look at what a webhook looks like within Kubernetes. So the way it works is for any API request against the Kubernetes server. So here we've got a pod, and we're going to create it. We're going to create a new pod against the API server. So we're going to do a REST call against the API server, say create this new pod. It's then going to go through a few things. The first thing it's going to do is it's going to look at all of the mutating admission webhooks that it knows about. And it's going to go through each of those and see if any of them, any of the rules of them match the request that we're making. So you can do things like label selectors and stuff like that. And any that it does match, it will apply them and mutate that API request. After those mutations are done, it's going to do a CRD validation to make sure that our object is still valid and can still be applied, or whatever the operation is. And then it's going to do, if you're on the later versions, 128 with the validating emission policies, it's going to do the same for those emission policies. It's going to go through each of them and make sure that your request is valid. It's going to say yes or no. And then it's going to finally do the same with the validating admission controllers, your webhooks here. It's going to go through all of those that it finds, and again, yes or no as to whether that API request is available. Now, one thing to be aware of here is, while this left to right order is set in stone, the order that the webhooks and the policies are actually processed within each of these columns is not guaranteed. Technically, as of today, it is alphabetical that it goes through them, but there's no guarantee on that. There's no, you can't rely on that, right? And somebody could come along with another webhook with a different name that kind of messes up your ordering. And so yeah, don't rely on like one webhook coming after another webhook. Once we've gone through all of that, finally, if everything's come back and said, yep, that's valid, that's OK, that's good, we can persist that API request into etcd. So after all of that, we finally have got to the end of our single API request. All good so far? Sounds great, right? So where's the risk? I want to give you a little excerpt from a Kubernetes blog post a little while ago. The emphasis here is my own, but yeah. Admission webhooks can be burdensome to develop and operate. Each webhook must be deployed, monitored, and have well-defined upgrade and rollback plan. To make matters worse, if a webhook times out or becomes unavailable, the Kubernetes control plane can become unavailable. The Kubernetes control plane can become unavailable. All right? This is from the Kubernetes.io blog. So even they're saying, look, webhooks, something can go wrong. OK, so I had a look at, collected a bit of data on some of our customers' clusters. I had a look at 129, which is a very frustrating number. I kind of wish that I could just created a new one just to round that off a bit. So I looked at all of these. All of these clusters had at least one validating and at least one mutating webhook configured in them. Overall, the average of all of these clusters was 9 validating webhooks and 7 mutating webhooks. The cluster with the most, with the single most validating webhooks had 25 defined, and the most mutating that I found was 15 within a single webhook. All right? And if we're thinking, if the Kubernetes blog saying these can make our control plane unavailable, that's a lot of risk that I'm seeing right there. And for clarity, like this number was from clusters of like dev, prod, staging, all sorts of different sizes, so it's all a variety of different things that I took this from. So how bad can things really get? So I'm hoping you're all kind of awake after lunch and are feeling full of energy, because I'd like to do a little game with you all. Very quickly, just through a show of hands, I'm going to go through a few scenarios of misconfigurations or malicious webhook that I've created, and I want you to tell me, through show of hands, if you think it's going to break the cluster in any way. In these scenarios where I was testing, it was using a kind cluster with version 128. Shouldn't make much of a difference, but just to be transparent. All sound good? So our first one is setting a different content type. So in this scenario, we are responding with a YAML document, but we are setting the content type header on our response to be XML. Why not? Who here thinks this will break the cluster? Nah, it's fine. It's fine. Kubernetes API actually just treats any response as JSON. Technically also handles YAML because of the library that they use, but it completely ignores the content type response header. It will just say, I think this is JSON, I'm going to try and parse it, and if not, then it errors. So that's fine. A cutoff response. So in this scenario, I'm setting a content length header of like 1 billion, whatever, and I'm actually just returning it an empty JSON object or something like that, or even just the opening parentheses of a JSON object. Who here thinks this will break? Yeah, cool. OK. Nah, this one's fine as well. So this one, the API server correctly handles. It returns an error to say, end of file. I responded to an error. This webhook, I can't, it's not giving me anything good to come back with, but it handles it in an expected way. Redirects. So in this scenario, my webhook is going to respond with a HTTP 301, I think I set it up with, a redirect request to go to another webhook that's going to do the same. I'm going to basically infinitely try and redirect to another webhook. Who here thinks this will break Kubernetes? OK, quite a few of you this time. OK, no, it's fine. This one's actually all right. So Kubernetes will do this 10 times, and then it'll give up. It's like maximum 10 times. Anything more than that, no, I don't care. Sorry, I am losing my headset. Cool. So you may be noticing a bit of a pattern so far, but let's see if that holds up. Reinvocation. So Kubernetes webhooks have this property called reinvocation policy. And this can be either if needed or never, I think is the other option, right? And this is for mutating webhooks. What this says is, if I, as a webhook, have been called and done an operation on the pod, and then another webhook has done a mutation on that resource, not necessarily a pod, sorry, do you need to call me again? All right, so it says, I always need to try and work on the latest version of whatever the resource is. In this scenario, I've got two webhooks, both of them mutating, they're always adding a label, and they're both set to reinvocate. So effectively, back and forth between the two. Who thinks this is going to break? Couple of you? OK, cool. That's actually fine. So in this scenario, it's triggered a maximum of 2 times. So you're guaranteed that if you have a reinvocation, it will only reinvoke once more. After that, tough. Kubernetes API is going to just continue on its way with whatever the state is at that point. So these 2 webhooks, they got called twice, and then it moved on. It's all good. So a fork bomb. So who here knows what a fork bomb is? Kind of thing. OK, a few of you, right. For those that don't know, this is it's not technically a fork bomb, but this is effectively a process that, when called, calls another process that calls another process that calls another process. It basically recreates itself infinitely. Right? And each one of those, yeah, exactly. So in this scenario, what I've got is a webhook that is set up to respond against all API types, or basically any API request. I want it to go through my webhook. But this webhook, upon doing so, will create an event within Kubernetes. Now, an event in Kubernetes is an API call to the API server, which will invoke another webhook, which will call another event, which will call another webhook. So it's going to infinitely keep creating. Who thinks this will break the cluster? OK, not as many as I thought. So it depends on this scenario. Very much depends. In a small cluster with not much traffic, you're probably going to be fine. It's going to keep going. It's going to always be doing this in the background. And the worst thing that's really going to happen in this scenario, in a smaller cluster, is your etcd is going to start to fill up. Hopefully, you've got enough space that it's fine. And those number of events is going to hit like 100,000, potentially. If you've got your event TTL set low enough, you're probably fine. But in a busy production cluster, we have seen this effectively denial of service the API server and take down the API server, because the API server couldn't handle the number of requests that were being made against it because it was infinitely spinning out a whole bunch of them. So be very careful if your webhooks inadvertently trigger other webhooks infinitely. You can take down your cluster, potentially. Data overload. So in this scenario, our webhook is just going to respond with as much data as possible. Don't care what it is, we're just going to pipe random data to the response, and the API server can then just deal with it. We're going to keep the stream open and just keep sending random bytes to it. Who thinks this is going to break the cluster? What? Not many. OK, you all think, yeah, this blew it up. So the API server died. Yeah, just became unresponsive. I had to restart the API server to get this back. It didn't handle that amount of data coming back into it. I was able to circumvent this by reducing the timeout seconds on the webhook. So if I lowered that down to 1 second, the API server had enough time to handle the closing of the connection before it fell over. But the default is 10 seconds. So if you're not overriding that, you're potentially taking down your API server with this. OK, so what's the actual risk? So we've seen a lot of these didn't actually cause much of a problem. They're not really the API server, you're going to lose your control plane that we were talking about at the beginning. So the actual risk is a little bit more nuanced. There's a lot of scenarios where webhooks aren't necessarily the cause of a problem, but they make a problem much worse. They make debugging a problem harder. They make fixing a problem harder. They make investigating why something's going wrong harder. Because as soon as things start falling over and your webhooks stop working how they're expected to be, it's hard to know what exactly is the cause of a problem and what's just a side effect of a webhook that's gone missing. So I've got a lot of examples down here at the bottom. If you're at the back, sorry, you might not be able to see the bottom here. But for example, the Reddit Pi Day incident from earlier this year, they had a section on a webhook was causing a lot of interference in their debugging, so they just turned off all webhooks so they could continue with figuring out what was going on, because otherwise there was too much noise. We've had some issues at GiantSwan where we've investigated where webhooks have effectively caused outages of the API server, and the API server's not been able to launch itself because it was waiting on an waiting on a webhook to respond. But because the API server wasn't there, there was nothing to call the no API server. It couldn't heal itself. And similarly, JetStack wrote about a similar thing a while ago with GKE and similar sort of thing. So the TLDR is basically, if the webhook in question within your cluster isn't built with resiliency in mind and can't handle things failing, it will block basically block critical path, right? It will block the creation of the API server. It will block the creation of the etcd pod maybe, or things like that. So if we think back to that beginning where I showed you the flow of an API call, we've got the API coming in, and then we've got all these webhooks before it even makes it to etcd. Webhooks are in the critical path of every single operation that your Kubernetes cluster does. And if you're not careful, they can break. Now, there are things you can do to circumvent this. So what is the fix? So webhooks have this property called failure policy, and you can set it to failure policy ignore. In this scenario, if your webhook errors in any way, returns a 500 error, whatever it may be, Kubernetes API server will go, OK, I don't need to run this webhook. I will continue on. Now, if you're using webhooks for security reasons, so as a replacement for some PSP functionality, for example, that's not an option to you, because you can't just have security not work if it falls over, right? You need your security features. Wherever possible, make sure you use namespace selectors and object selectors and things like that. So on the webhook manifest, you can define what resources it will work against, and the API server will match those against every request. Wherever possible, have it ignore the kube system namespace, because you do not want those pods getting blocked by these issues. Do you even need a webhook? A lot of third-party apps that you'll see these days kind of just throw in a webhook because it makes things easier. It makes some of the defaulting logic and all that kind of thing as part of the initial API request. But it also adds in all this risk that we've seen. Do you actually need that defaulting logic at the very first creation of the resource? Or can it be done asynchronously? Can you have a controller that watches for these resources being created and updates them afterwards? And will that still work? During an incident, if you're dealing with a P1, if all of your customer's data center is blowing up or something, maybe it makes sense to disable webhooks while you're trying to get to the bottom of it. If they are causing red herrings, they're causing you to look in the wrong direction, it may be, as a kind of a quick case, disable them all, delete them, whatever, let pods recreate, etc., whatever it needs to be, and then reapply them afterwards to see if that was preventing the fix that you were trying to apply. But that's not always feasible. You have to see in the particular instance. But finally, what we do have with, as I said at the beginning, with 128 and onwards in beta support, we have this validating admission policy. And if you can use it, if you have validating logic, not mutating logic, if you have validating logic, you can make use of this validating admission policy where possible. So let's have a quick look at what this is. This was introduced as a KEP back in 2020, about a year ago now, actually. And this follows on from another one that was applied to CRD conversion specifically. But the idea of this is it allows you to use CEL, C-E-L, which stands for Common Expression Language, to apply validating logic against a bit of data. The data in this case is an API request to the Kubernetes API server. And that allows you to validate things such as the resource itself, so the pod, the deployment, whatever, the actual API request, so whether it's a get, whether it's a delete, etc., and do like a yes, no, this is OK. This is all performed within the API server itself. So the API server has CEL libraries built into it, so you don't need to call out to another service that may be unavailable, that may be, infected or whatever. You are all within the API server. But as I said, it's only for validating, not mutating. So let's have a little look at how you might use this, because I do think this is the way forward for a lot of these cases that we've seen. This introduces two new resources. So the first one we're going to look at here is a validating admission policy. So this allows us to define what our actual validation is. So in this scenario, we're looking at the match constraints and the validations. So the match constraints are our set of filters as to what we want to apply it against. In this scenario, it is the creation and updating of deployments. Everything else, pods, secrets, blah, 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 they'll all be ignored by this policy. And then finally, we've got the validation. We can have multiple of these, but in this scenario, we've got one, which is we want to validate that the number of replicas set is more or equal to 3. We want to make sure we've got at least 3 replicas for every deployment within our cluster. This is going back to that best practices use case that we said at the beginning, making sure we've got some high availability of our deployments. And then once you've got that, you use this validating admission policy binding, which is quite a mouthful, that allows you to take a policy and bind it to your resources. So in this scenario, we're taking that policy we've just seen. We're saying that the validation action here is deny. So if it's not validated, we will block that API request. You can also have it here as warn or audit, so to still allow it to go through, but flag it up. And then we're going to say match resources. So here, we only want to apply this policy against any namespaces that have a label where environment is set to production in this scenario. So what does this look like? So if we're creating a deployment within a production namespace with a single replica, this is the sort of thing we will see. So it's quite wordy, but the deployment's basically blocked, saying that it needs to be more than 3 replicas. Now, this isn't very pretty. A very quick example with like the minimal amount of specification you need within your validation. Cool. The validating admission policy also comes with a whole bunch of other features. Have a look at the documentation and some of the blog posts that Kubernetes has put out. There's a lot of information in there. As I said, it's still beta, so there's still more kind of being worked on the stuff. But you've got some things here like you can work with parameters and variables and things like that to make your validations be based on other things as well. So you can, for example, have another resource that defines what your limits are and then use those within your validation so that you can centrally control a value that you can change easily, and it applies to all validation policies. You've also got things like warning messages. So rather than having that ugly message we just saw previously, you can actually give it like a human readable one of like, this deployment needs to be HA. You need at least three replicas. And you got things like auditing and all this kind of stuff. Cool. So to wrap up, webhooks are rarely the cause of incidents, but they can. They do have a tendency of making things considerably worse, especially if you're in a panic state during a P1 and a webhooks, and you're seeing that the API server pod is just not being created. It turns out that's actually because it's trying to call a webhook. It's not great. Beware of that critical path. So that API request where you've got all of those webhooks in place. Thinking back to the clusters we looked at earlier, 25, I think it was, webhooks that have to go through, that have to be gone through for every API request. That's quite scary now. We've seen like how much they can break things. if you are building webhooks, make sure they're resilient. So make sure you are replicas, anti-affinity, making sure that you have label selectors, etc. And please, wherever possible, when it's available within your clusters, make use of the validating admission policy. If you want to make use of this today, you can try it out with 128, but you have to enable it through an API flag. But I do recommend you trying it out, see if you can replace your validating admission webhooks with the validating admission policies. Thank you very much. I would very much appreciate any feedback you have for me. If you want the slides or any of the resources that I've mentioned, you can find them on that link at the top. And if you're interested in the code that I use to produce those scenarios that we talked about earlier for the little game, you can find it down at the bottom here, also linked from stuff at the top. Thank you very much.